Alright. What are we working on here? I should probably check my sound. Yeah, it looks like my sound's good. Hey, Morrison, how's it going? We are just hanging out, working on the lab still. I got past some of those problems we had from earlier where I just couldn't, once I went to deploy them via Ansible, I couldn't get the deployment to work. And I got past all that stuff by just going back and looking at how I had built some of the stuff before, and I got it all set up. And now I'm on to this next part where one of the things I want to do, let me see if I have an old lab here. Go into my ProLUG presentations and go up one to our Linux group. And I've got a whole bunch of old labs here, right? And some of the labs we couldn't do because I didn't have any tools for you guys to get in there and do them. I mean, we could do them like one-offs and stuff. But I have, where are they? I want to say they're, maybe it's one of these ones. Oh yeah, shoot, back when you used to have to rescan discs. That was fun. That's not it. That's not the right one. Let's see. I might not have it in here. I might have it down in some tool chains and pipelines. Might have been some of this stuff. I might have it in some of my older stuff. Discs. Yeah, LVM and RAID. Here we go. This was an old one that I had built for AAA way back in the day. And let's see. Disk tests and speed. And then doing some of the LVM stuff. And then go in here and build out some of the disks. So I'm gonna update this document. Copy a version of this out to my normal stuff out here. And rename it. We'll just call it lab and VM RAID. And I'm going to update that. I won't do it right now, but I'm going to update that and make sure that I have the right stuff in there, because now when people jump into these nodes, they're going to be able to do configurations once they come back up. We got to verify that they're all going to come back up, which is a big part of this. Now that they've gotten some new stuff put on them, they should be coming back up. We should have everything working. I mean, I've done a few reboots since I was last on earlier, so we're gonna kind of test a little bit of that out, make sure that everything's coming back up the way that it should. And then you know, provided that all works, then we're pretty close to having a pretty good lab environment. And then I thought about it. I think I'm gonna figure out a different way to get access. We won't worry about those keys like we were doing. I think we might do, I don't know, I'll figure it out. I guess I could do certificate based, or I could do, I could just set a password. And I don't think that's that big of a deal. I think that should be fine, because nobody ever sees it. It's all part of the back end of the system or whatever. So anybody that got here late, we were going over this earlier today, and then I kind of took a little break, and now I'm coming back, working on a little bit of stuff, got a little bit more energy, and I'm looking at the nodes to come back up after the rebuilds, making sure that they're coming up, and it looks like they're all rebooting without problems. Yeah, they should be coming back up with their right personalities. These are stateless nodes, so when they reboot, they build themselves every time. Every single time they pull a new image down. So when I just went and rebuilt the overlay and added in the logical volume management stuff that we needed, right, to be able to do logical volume management stuff, those boxes are going to wipe themselves back to unconfigured. And then, so that'll happen on these. And then when they finally do come back up, what'll happen is when we log into them and do any of our configurations on them, we can just reboot the boxes and then we'll come back to nothing. And you might say, well, why is that all that important? Well, because in a lab environment, you really want to get back to like 0 very quickly. So I want to be able to go to this node 1, right, which is now up, and I want to be able to say fdisk-l grep-i for xvd and see the 3 disks. So I have the one primary disk, and then I have these 3 other disks, C, B, and E. Who knows why they got their names like they did? That's fine. I don't really care how they got their names or what they are. And then I do like a PVS. We still don't have a PVS. I rebuilt the image. Huh. Does not look like this system came up with the rebuilt. Oh, hold on. I may be dumber than a box of sandpaper. Hold on. Gosh. Damn it. Let's go check something, guys. Let's go look at our nodes real quick. Don't worry about the node set. Let's list. Oh gosh. Well, so see the Rocky Linux 9 here, but I updated I updated the 9 lab. So what we need to do is we need to boot these boxes over to the 9 lab container image, and that's actually good. So we'll redo this real quick. So this one node, we're just going to go set this one node to be that other image. So node set, we'll say Rocky 1, and then container is going to be equal to Rocky Linux 9-lab. That's what I had called it. So we'll set that. We want to modify it. We're going to rebuild just his overlay. So just that one node. We won't rebuild all the other ones' overlays because there's no reason to right now. And then we'll kick that node over. And just force the reboot on it. It's fine. All the other nodes should also have come back up. So they should all be back to their starting. But they're on the other one as well. So they're on Rocky Linux-9. And Eighth Gata, hopefully this stuff's useful to you. And David, I missed you earlier. You're probably not still around, but thanks for the follow. Cuddlingless, WWCTL part of Warewulf. Yeah, it's actually their command. It's like their whole command and control setup, yes. So WWCTL is their kind of their little command set. Yep. So if you look up and down just my history, it's all just WWCTL. And the way I eventually found out, so I was working earlier and we were trying to get the Ansible to work for the deploy, and the Ansible works for the deploy. However, the way the nodes were coming up wasn't working. So I went back and I worked on just the one node, and I got just node 1 to work. And then I went and set nodes 2 through 5. I took 6 off. So I just did 1 by itself and then 2 through 5 as part of the Ansible deployment. And I got that stuff to work like I wanted it to. So I'm like, okay, this is good. I've got everything clean. Yeah, it's a Warewulf command. Yep. It is part of where it is the overarching control of everything Warewulf. Yeah. And there's I linked it earlier, but I'll send it if anybody's interested. There's a fair amount of just good information in their documentation here. So I'll link the documentation to people that want to go spend a little time and see if this is something that's maybe interesting to you. You know, you want to go spend a little time in there, you know, looking at how Warewulf builds and all that stuff and what it is. It's been around for a while, and it's actually surprisingly good. Like I've used not XCP. I've used XCAT for a long time professionally, and this one is also pretty good. I'm not gonna knock this one at all because I think it does pretty good. Let's make sure that my node 1 comes back up. So here's how I'm going to watch it. I'll just ping it here and I'll watch it at the console. We grab a couple of, the responses are coming back here. So on the console, I should see it here shortly. Hold on, I'm going to grab some water. Don't worry, I don't have to go far for water. Got it over here in my fridge. My office fridge upstairs. I always joke around. That's how I knew I had made it, was when I had a fridge upstairs in my office. Didn't have to go downstairs anymore. All right, so it's responding on ping, which means it's probably after about 20 seconds. Most devices are going to be nope, not yet. But about 20 seconds of ping for most physical boxes, you'll be back up. We're on a virtual machine, so I would have thought it was faster. That's fine. Hey, Robedom, how's it going? there's our Discord. Robodom's posting that. I was on earlier and I was building these out, but I got stuck a few times and I just kind of went and took a little break and kind of hung out. I watched some of The Boys because that's on Netflix or Amazon Prime, so I gave that a shot. That was okay. I was like, that's about what I expected from reading the reviews and stuff, you know. This has been taking ping for quite some time, but now it should almost be up. There it is. All right, so we're in Rocky 1. If I do PVS, VGS, LVS, there we go. We've got the command now because we have properly assigned those things. If I do an fdisk-L, grep-I for XVD, there's my disks. And I have an A, a B, a C, and a D. And if I did just fdisk by itself, actually it's funny, if I do a df-H, I should see how everything's mounted on my system. And everything on this box is actually mounted as tempfs. So that's kind of good. Interestingly enough, since this is all tempfs, I don't see any of my disks being used, so that's fine. But I have a much smaller let's see here. I've got a much smaller disk here. Also, it's weird to me that it's the FS tab, right? And see, I should be able to mount -A and see there's my home and my opt. So there's those files that are you know, kind of bigger where we can go put things if we need to, right? And then everything else, yeah, this is a pretty small tempfs. Let's go look if the other nodes are sitting on that same configuration. df-H here. These boxes are the same because they're all tempfs. However, they did mount Rocky 2 correctly, or they did mount the 2 mount points correctly when they came up. So that's an interesting thing. On Rocky 1, we did not have the NFS mount points until we did a mount manually. So that's an interesting little thing. Okay, so let's see. We've got a couple of other things to do now on these nodes. So we just set earlier node list. We set this one container to that. So now we got to set 2 through 5, 2 to 5. We're going to set that to the right container. We're going to modify those 4 nodes. Yes. We're going to rebuild their overlay, which is 2 through 5. And it'll build just their overlays. And then what we're going to do is we're going to kick those boxes over. So I actually have the commands right here, so I'll just do it in here. Here's 2, 3, and you know, I could just loop it, but it doesn't really matter. So 2, 3, 4, and 5. We don't need to write a loop for that. It's small enough for now for what we're trying to do. All right. So, oh yeah, thanks for the anonymous gift sub for Ponies for All. Who knows if they're even here, but hopefully they get the anonymous gift sub notification. It's always a good thing. I appreciate that. Keeps me motivated. Keeps me working on stuff, right? What are we doing though? We are just setting up Warewulf on an XCP NG cluster. We've gotten these nodes set up where they are booting properly. They are pulling the config. We just reset the configuration to go over to this other one, which is Rocky 9 Linux Lab. And in that lab, they are going to have, if I switch to Rocky 1, they're going to have PVS, VGS, LVS, but none of them are being used yet. And then they also are going to have MDADM on them. MDADM is a tool that we can use for partitioning. Sorry, not even partitioning. We can set up RAID at a software level on the system, right? Not a hardware RAID, right? Hardware RAID is different. But inside the system, we can set up software RAID in case we need to. I mean, I guess there's different reasons you can use software RAID. You could have maybe some attached disks and you need to ensure that they are built in such a way that they're redundant in case any one of the disks fail, that kind of stuff. I guess you can do that kind of stuff with MD80M. A lot of people are big fans of hardware RAIDs because they tend to be faster, but software RAIDs are fine, especially when you're using virtual machines and you're not really too worried about the ephemeral stuff that exists out there anyways, you know. Let's make sure our nodes all boot, right? That's what we're keeping an eye on over here. We're making sure that they are getting to a good run level and they're starting, which they should. They're pulling their new version. They're coming up properly. They're not having any of the problems that they were having earlier, right? Although the one thing to note and the one thing to watch is that they do only have a temp FS on them. So if I df-h here, this box is using much more of its root because it's sharing that out and allowing that to be used for the temp FS file system. So that's a little important thing to kind of note here, that you know, these are not on the local disk anymore. These are not down on that 15 gig disk that this box originally got, these temp FS file systems here. So, and that also means we might have to go tune how big temp FS is, and we may have to make the Warewulf drive bigger, because as we add more and more nodes to this and as we go and do more and more stuff, there's going to be more and more kind of stuff to mess with. Okay, so since we got this part all done, what we can think about doing is maybe going and grabbing... We've got the public key for lab user. So what we could think about doing is building that into my Bastion system so that we could come through, because some of you guys have seen that we've got a Bastion system and we can connect into that and we can pull down information from, well, anybody can connect to the server if they have the right information to connect, right? So we have an ability to get in there and hop into all of these other nodes, these dungeon nodes that we have. But these new Rocky nodes, which are just Rocky 9.4, they are nodes that you would be able to access and then go do some disk carving type work on, right? I want people to be able to carve up and do disk work on there. So let's see if we can get Rocky 2 yet. Should be coming up soon. Says it's still booting. Let's see if it comes up. Yep, there we go. So it's up. PVS, PGS, LVS. Good, it's all there. I mean, we expected it there. Robodom, it's actually really good. We've got Warewulf going. These are all partitioned from the... They are provisioned, let's say. Not even partitioned. They are partitioned, but they're also provisioned from the Warewulf system. Meaning, if I just go kick any one of these nodes over, if I just reset this node right now, when I reset it, it will go back to being the base system. No matter what people have done to it, it's almost like a trapdoor. It'll just fall and come back up and there'll be nobody on it, right? So the reason I'm doing that is because now when you get into one of these nodes, let's go see if Rocky 3 is up. Yeah, as you get into one of these nodes and you do your fdisk-l, grep-i, xvd, here's your disks, and then you say, okay, I want to do some of that PV create and set up dev xvdb, right? And then I want to do xvdc and then xvde. So then now if I do PVS, I have these 3 physical volumes on here, and I can start to take those and aggregate them up into volume groups and then carve them down into logical volumes, and I can start to learn how logical volume management works if I don't know. And that's why I was saying I'm going to take this lab that I've got here, and I can start to carve this up and show some of these different pieces. I got to clean this up, but this is we've got these individual devices, and I'll change the names to be the Rocky servers and stuff, but we'll be able to get that kind of set up and going. Yeah, Robodom, I think a lot of this stuff, I mean, this is, one, something I like doing, and two, this is something that also directly goes into like what I'm doing professionally now. I'm using a lot more Warewulf clusters. So by building it in the home lab, I've literally just the last 2 days I've done 400 WWCTL commands. So I feel 400. 300 to 400. There we go. Trying to get the closed captioning to not tell you I'm doing 3,400 things. Like, that's insanity. No, but I've done a lot of commands. Like, if you go look at my command history on just this box since it started, right? Even when I'm fumbling around, there's a fair amount of, I'm adding my user, I'm setting up the firewall. A lot of this came directly from the configs, right? Started to add the different systems and the disks and all the different things that we were doing in this environment, right? Look at all these different commands, and even if I didn't know all the things they did, I've now done quite a few of these commands, right? And I'm starting to get a lot more confident in how they work. They're not all WWCTL commands, but there's a whole lot of them, right? So this is what we do, right? We slowly figure things out. We slowly document our solutions as we go. In this case, I was looking at one of my old lab disks and trying to figure out how my profile was set up so that this worked properly. This was one that had never worked, but I had already blown away the lab disk 01 that had worked. So I was kind of face palming because I had blown away my configs without saving them. So I didn't have a working one to go against. But over here, maybe I'm in this node back in Rocky 3 PVS. Those things are still there, and I can start to do VG create. Maybe, I don't know. We'll call it like volume group. I don't know. Maybe store. Maybe we call it. I don't know. Data, right? Data vol, or whatever we want to call it. We just call it data, right? VG create data. And we'll do it from dev xvdb, dev xvdc, and dev xvde. And now some of you might go, well, that's super easy, Scott. And I go, yeah, some of this stuff is kind of easy. You just got to spend some time doing it. And then you get a little confidence, and you're like, that's all it takes to do like logical volume management. And I'm like, yep, that's all it is. And you say, well, how often do you do that? I don't set up logical volume management very much. I might set it up in an environment just for like a test like this, like I did. But we don't spend a lot of time doing this kind of stuff. This isn't, too crazy. And then from here, we'll do an LV create, right? And we'll carve down a set of these. We'll carve this down into, so LV create, and we can even throw a dash help on it if we need help. And we should be able to LV create our pool, right? So LV create a logical volume, and we should be able to go against that volume group and pull down. Yeah, should be something like this. Let's just call it, I don't know, data. We call it data, and we can use the if we hit this, it'll say nope. You need to add in. So typically then you give the, what is it, the volume group. You can make stripes and you can make all kinds of stuff. I need to make sure that I have the volume group. How's that at? We can do a L size of, yeah, and then there's a volume group. There it is. Okay. So, and then we should be able to give, where's the, I thought it was dash name. So here's how we can do this. So there's dash N for name. And then we should be able to give dash L, and let's just say 100 plus 100% free, and then the volume group, which is dev. Where's the volume group? Hold on. The volume group is data. So there you go. Grab this. Right click, and the volume group is just data. N is ambiguous. Oh, it's one N, one dash for N. My bad. Can't parse argument size for size. Oh, you gotta use either an upper or lowercase. Plus 100% free. Lowercase L. There we go. Now we do LVS, right? I'm a little rusty, guys. Now I've got a data volume, logical volume that's as big as anything else. But here's the thing, right? Oh God, I wonder if I have it. We need to make a file system on there now, right? Because you can't just mount that, right? I was at my on-call job earlier, and you're gonna catch us on Sec Plus studying tonight, Robodom. Good. Yeah, Sec Plus is a good thing to spend time with. Make sure you're reading that, watching some stuff on YouTube, maybe getting in there. That's definitely valuable. Let's make fs dot. Make fs dot, and let's see if we have any of these. And let's say we want to do. So ext4 or xfs are typically what you're going to run into now. Let's say we want to do xfs. XFS. So make fs dot xfs against dev mapper, and then the logical volume group is going to be the volume group name, and then the logical volume. So I call them both data. So well, there you go. So I can make a file system on that one, and then now with that file system made, I can just mount. I mean, I could just make a directory anywhere in the file system called like stuff, right? And then I can mount stuff to. But by the way, I can give the type explicitly if I need to, but the system tends to be smart enough to go find it. So I'm just going to say mount dev mapper data to stuff, right? And then if I do that, and then I do a df-h, there it is. There's my dev mapper data mounted to stuff. And if I do a mount command, grep-i for stuff, yeah, just stuff, I would see that it's at type XFS. It's mounted on from there, right? All this stuff. Then we got these other commands. We got like ls block, and ls block will tell us stuff. Block ID will tell us stuff about how things are used in the system, and these are part of logical volume management, so they're not to be handled or touched in other ways in the system, right? There's all this stuff, guys. There's like all these things that we can do, and one of the reasons I've been so keen on getting this lab up is because watch this. I'm gonna show you something in this lab. I'm gonna reboot this box, right? Just rebooted that machine. I did all that work on there, right? And I just rebooted it. And we're gonna sit here for a second. I'm gonna ping that box while it's down. I'm gonna come back over here, and I'm gonna hang out and watch it while it's down, and sit here and drink my water a little bit while I talk to you guys. And then we're going to, when this comes back up, we're gonna go look and see if any of that disk configuration is still there or if it's all wiped. And I'm gonna tell you it's all wiped because, well, there's no memory of it. It's like Gandalf. I have no memory of this place. Watch, it's gonna boot up. System's gonna come back up, and none of those changes I made are there. So you say, well, Scott, what is that? Why do you care about that? Well, because when I give people access to this, they're going to be able to go in there, carve that up, do their logical volume management stuff, reboot the box, move over to one of the other ones, do the MD-ADM stuff, and then bounce out. And as long as the box reboots, and I'll just make them reboot every night, they're going to come up clean. And they're just going to be ready for the next person to use whatever they want with them. And that's kind of my goal because, again, the Killer Coda stuff is awesome, right? Like, I love Killer Coda. We're going to be doing labs in Killer Coda tomorrow, right? Get in Killer Coda here and do all kinds of cool stuff. But I can't show you disk management stuff in here. There's literally nothing in here. I asked them one time in their Slack a while back, probably over a year ago now, and I said, hey, no, Robodom, I can't. Because they don't have the disk stuff. I've asked them, I've said, guys, hey, can I have just like 3 small little disks in a lab environment? And I'll show people how to do all kinds of cool stuff with disks. And then once we build the disks up, guess what? Then we'll do speed tests against them, and we'll do all that other stuff. And they're like, no, we don't have any plans for that going forward. And I was like, well, I mean, if I want to show people in the professional Linux users group how to do this stuff, the only way for me to do it then is to build the labs myself, right? Like, so there's awesome labs out here. They're free, but these labs here are for us internally, right? By the way, I'm getting pings back. I've been getting pings back since the 75th second of this being down. If you say, how do you know that? Well, these are 1 a second. So after 75 seconds of me pinging it, the box came back up. And it's still booting, though. It's not all the way down. It's responding to ping, meaning IPv 4. The TCP/IP stack is up, but the kernel is not yet to SSH. So one of the things I should probably do, well, there's no easy way for me to give that, but if I gave access to this, then you guys would be able to. I can turn off silent boot, and you guys could watch the system boot, right? That's a very valuable thing as a systems engineer, to know how your system boots and what does it mean to walk a bus, and what does it look like when a system boots correctly versus when it doesn't. It's been 100 seconds almost, so about almost 2 minutes since that finished coming to there. Let's see if SSH is up yet. It's not up yet. I didn't think it was up yet because I don't see it over here. I don't see it connected over here. Hey, thanks for the follow, Aerogent. Yeah, hopefully this stuff's useful to you. There it is. There it is. So now it's coming up. It's almost to SSH. There's SSH. It's not quite up yet. Hold on. We'll give it a few more seconds to come up the rest of the way. Nope, still not there. Still waiting. Give it a second here. So we try to do around here. Do all the Linux. Show people that you guys can do this stuff. Sunday mornings we just hang out and do labs, right? So I'm going to try to get some of these labs up, so if people want to hop in and have access to these Rocky boxes, they can. We'll give it, man, it's taking a little more than I would have normally liked, but that's fine. I mean, we're using these for, there'll be, people doing other stuff and being able to jump into other boxes, so it's not that big of a deal whether or not a node comes back very quickly. But PVS, VGS, LVS, that's interesting to me. That it is still carved up, so those are still carved, so that's interesting, probably because the data's still there. But in my df-h they are not mounted, so they are there. We can blow them away, right? We can destroy them and rebuild them back up. So this is what we're doing here. We're just in the system. All right, give me a second here real quick. I'm gonna go to a little different. Let's try go back to our streaming dark. That was fun earlier. Throw my streaming dark stuff on, right? Some of our different music that we have available. Oh, okay, so I know that those will stay carved. So we either need to tear those down. Well, no, actually, that'll be good practice too. They're not mounted, so we can do PV, or we can do LV destroy, right? Got LV display. It's LV remove. Sorry, guys. We can do an LV remove of data. And it says, do you really want to get rid of this one? And we say yes. And then we do a VG remove of data, and it says you remove that, and then we can do a PV remove of all of the different disks that we have: dev, XVDE, XVDC, and XVDB. And then if we do a PVS, VGS, LVS, we're back to all of the disks are kind of back to just hanging out and ready to go again. So what I'll do is I'll set this lab up where if you come to a box and they're all configured, you can just wipe them, right? Because they won't be mounted. And it'll tell you how to delete everything, which is a useful skill. And then from scratch, we will build them up. And then once we've built them, we can go and test, the right speed to them and all that kind of stuff. So I think that'll be a fun little practice thing for everybody. And if you go work for a company as a systems administrator and then eventually as a systems engineer, you will be working with disks. And sometimes those disks will be in logical volume management. Sometimes they will be in just raw partitions. Sometimes they will partition them up and then put them into logical volume management, and sometimes they will just be raw disks thrown into logical volume management. So there's all kinds of different ways that this can kind of happen in a system. And this is one of these things where we want to be, we want to be able to get into any of these boxes and see, what's going on with the system. So, all right, I'm pretty happy with how those are working. So these disks are doing the kind of things that they need to, so that's good. Now, the next part of this that I guess I got to decide if I want to work on this or something else is getting access into here. So we have the key for the user, and we know how the key is created, but for some reason the key is asking for a password, and there shouldn't be a passphrase needed. So I hadn't really dug into that much on the Apache Guacamole side, but we could do that for a little bit. Or we could, well, we don't really have to work too hard today anyways if we don't want to. But what else could we do here? We've got, I think what other things I got going on in the home lab environment here. We could do more Prometheus practice, because I'm going to take my PCA probably at the end of this month, which is a Prometheus certified thing. So we could do that. I could leave it up to you guys to decide if you want. I guess it doesn't really matter what we end up doing. Also, it's kind of weird. I keep getting a weird warning over on the YouTube side that I've got a stream bitrate kind of low. So I don't know what that's saying, but I guess I should probably read that. Hold on. Lower than the recommended. It says we got a good connection though, so maybe that's fine. What else? We could start the security talk stuff, but we can't finish that tonight, so maybe we'll wait on that one a little bit. But we got some security stuff we can do. Somebody mentioned the other day talking about AWS certified cloud practitioner. Are some of you guys thinking of taking any of the AWS certs? Because I could talk to those until I'm blue in the face. If people want that. If you guys want me to talk about that a little bit, I can talk about those. Or we could play video games. No, I'm just kidding. We're not going to play video games right now. Video games are like a mixed bag. If we go do those too much, we'll just want to mess around with those all the time. And you might take that, Robodom. Well, we got good resources on it. But yeah, focusing on your Sec Plus might be really good. Might be a really good thing to start with. You know what? We could do would be kind of fun here. I'll talk. We could talk some security. What if we talk some security, but we go about it this way? I have a document here from James Frankenreicher, right? Or Martin Frankenreicher. And you can use it for any non-commercial purposes. So in this case, we're just hanging out, talking shop, right? And we can walk through some security stuff if you want to talk about security type concepts, Robodom. This will probably be good for you studying for your Security Plus. Even though this isn't directly Security Plus related, this would probably really help you get ready for your Security Plus. In fact, I can think of some things that would probably be the best place to start for some of your Security Plus stuff. Hey, let's hop down here. We'll talk about this, and we'll do this. We'll do network and communication and network security. We'll start here because this is some of the stuff that's gonna be like the most in depth as far as like the stuff that's gonna be on there, and we'll talk through some of this stuff, and then how about we do that? I think that would be a fun little thing to do. We talk through some of this stuff here. Plus, this is stuff I know the best right here. And then we can go talk about access and that kind of stuff too. But I think this stuff's going to be some of the most important stuff for you to know because this ties the closest into like the Network Plus side of security stuff as well. So I think we can talk about that a little bit. All right, so here's what we'll do. Man, this thing keeps jumping to the damn right on the YouTube side of things. It's kind of weird. I don't know why it keeps doing that. But here's what we'll do. We'll take a quick break because we're already, we're almost an hour in. Take a quick break. Put it on Ranger Cam for a second. Oh, Ranger's down by my wife. My wife has some friends over. Some of her girlfriends came over and they're playing games downstairs. That's why I hopped up here and got back on stream. I was avoiding the Settlers of Catan and other games that they were playing. Yeah, yeah, we're just kind of hanging out. Let me throw a little thing up for a second. And we will take a quick break. And we could do... Oh, we could do some... Man, we have to do some lab maintenance, too. That would be good, too. Do some lab maintenance. But we'll leave it on Ranger Cam check for now, even though Ranger's not down there. And we'll come back and... yeah, I've heard good things about Settler, but it's not my type of game. I don't like getting around and playing resource contention games with my friends. That's... I feel like... I like the games like... I'll tell you guys the games I like when I come back. Take a break. Be back at it in a minute. Talk some security stuff. All right. No Ranger. They took his bed. So he's sitting over there by them. So they're out there playing, doing whatever they're doing. Now I could throw Mechabellum on, but problem with Mechabellum is, I don't know if you guys have seen it. I'd probably have to go change what category I'm in. That's just too much work. So we'll just keep doing tech stuff. We'll do tech stuff. It's good for us. Keeps us sharp. Keeps us thinking through different topics. It's valuable, right? All right. Keep taking a break if you want one. We'll start here shortly. Let's go check on the lab. How's the lab going? Waiting for these things to finish booting. Yeah, lab's good. So the devices are the way I want them. They are booting up the way that I want. We could make some of this work better. Where's our temp FS coming from? This over here for a second. Move the connection. What do we got here? Those are just the images. So I wonder where they're sharing out. I'm gonna have to dig into this a little bit. Where TempFS is being shared out from. Rubedom, you sent me something through Discord. Let me check. Let me check here. Hold on. I didn't. I don't know. It's weird. Yeah, I don't remember banning anybody on my birthday. Normally I'll ban somebody if they're being crazy, but I didn't ban anybody on my birthday, I didn't think. Okay. Yeah, good. Alright, good. Appreciate it, Robodom. Alright, let's get this. We're done. We're good on our break. Let's do some security talk. We're using a tool that's out there for free from anybody that wants to use it called the Sunflower Doc. As I mentioned, I gave credit to the Martin Frankenreicher, who originally wrote it. And we're just talking through some of the pieces. So if you're thinking about getting into, cybersecurity, even if you're not going to go take the CISSP, you say, hey, Scott, I'm not going to take $795 test to do cybersecurity. And I say, that's fine. Not everybody wants to do that. Or you might say, hey, Scott, if I wanted to spend that much time doing cybersecurity, I would spend it a different way. I would go do like an OSCP or something. I say that's perfectly fine, or certified ethical hacker or something, right? Morrison, you just have to. This one is on my system, but you can find it if you just Google Sunflower CISSP doc. You'll get the PDF. It'll be the first thing that comes up. I'll link it to you guys. It's the first thing that'll come up for anybody that wants it. It's an excellent little resource for when I was in the last little bit of my study for my CISSP. I would keep this up on one of my monitors at work and just kind of check over at it as I was going. So they have this little thing, man. I've been teaching networking for 16 years at the college level. Mostly I teach computer networking, but also pretty much anything computer security and computer networking and Linux related. But they always talk about this acronym, all people seem to need data processing. I think that's fine if you struggle with any of the other stuff, right? But the idea is you start up at the application layer at layer 7, and the data travels down from one machine to the other. I've got a pretty good visualization of this, but they're talking about application layer 7 over here, then presentation, then session, then transport, then network, and then they go all the way to data link, and then physical. So we're kind of working down through the layers. I have another way to visualize this in my talk, and there's a whole talk on this, so I'm not going to go deep into this one right now, but we've got a little primer on networking, right? So if you struggle with networking and you're like, hey, I need to work more in networking, this was from a primer video that I did. This is on YouTube for people that want it. And as we talk through this, we get to OSI. So the data travels down from layer 7 down to layer 1, goes across and goes back up, but each layer logically talks across to the other layer, right? They talk up and down between themselves as they flow the bits down. They flow as bits across whatever type of media that they're using. That media can be physical or wireless, and if it's a physical form of media, it's typically some type of electrons flowing through copper cabling of some type, and then it's photons traveling through some type of fiber optic. If it's wireless, it tends to be some type of propagation of radiation in the form of electromagnetic waves, or in the form of laser light, which again is photons, right? So yeah, and by the way, if I sound like a college professor that's been talking about that for 16 years, boom, there you go, right? That's what I talk about. And there's a whole talk on this. So we're not going to go over too much, but this is how the data flows. I'll leave this up because we're talking networking, right? So then as we come in here, they start up at application layer 7, and you should know that these are the things that exist up there. Your FTP exists up there. FTP exists up there. Your telnet exists. All these things start up there, right? And then they move down. SMB is the underlying technology of Samba, and it's how we communicate. Server message block was actually written by Microsoft. A lot of people don't know that. SMB was written so that Microsoft interface could interface as a system with Linux boxes in the early 90s. Did you guys know that? Microsoft wrote it. So if you've ever used the tool Samba, if you've ever been on a Linux box like this, and we jump over to just one of my normal lab things in SSH to hostbox, and I do my little test parm, and then in test parm I see my connections over to my Samba shares that are out there, and then I think some of you know that my Samba shares, I can jump down into these shares whenever I want. I can go down into like my ISOs, and I can see all my ISOs stored on the Linux boxes behind me, right? So here's all my ISOs, and then this Samba share that I can connect in. And remember, just the other day, guys, we dropped in there this Rocky 9.4. Some of you guys remember, and that's what we put Warewulf on. And then after we built Warewulf, we downloaded all of those other little cluster tools, and now we've got Rocky 9.4 all over in our environment, right? But this is how we did it. We put it in here, and then over in my XCPNG, these devices, all of these are part of an NFS ISO library that's shared out as NFS. So I have the same share going through everywhere. Hey, PowerSpan, how's it going? Thanks for following and coming over from YouTube. You guys you're always welcome to hang out and talk shop. We are doing some security talk. We're using a tool that's out there called the Sunflower CISSP doc, and I'm just talking through some of the pieces. I know I'm jumping around a lot, but one of the things I try to show you guys is there's all these different technologies and stuff, but then there's also the, practical hands-on part of it, right? There's the rubber meets the road Linux doing, whatever. This is a PuTTY terminal into Linux with screen session running so that if I kill the screen, in fact, my box rebooted late last night, and when I came in this morning, I just reconnected my PuTTY and turned screen back on, and everything was up. Yeah, PowerSpan. I'm a lot like a professor. I am actually a college professor, by the way. I've been teaching at the college level for almost 16 years now. So hopefully I sound at least a little like a college professor. In fact, I've had a couple of my college students find me. I don't really advertise like to my college students that I also talk on Twitch and YouTube and stuff, but people have found me. Some of my engineers, I've taught hundreds of engineers over the years. Maybe even not quite. I haven't had quite thousands of engineers in the professional space, but in the college space, I've had over 5,000 students now. So yeah, I got to yell at you guys. And do you guys all know why I yell at my college students? I know Fisherman and Robodom know why I yell at my college students, but does anybody else know why I yell at my college students? Because they're not going to yell at themselves. All right. Anyway, so we can secure with HTTPS. So that's SSL, right? Secure Socket Layer. Although the SSL technology, the underlying TLS technology, is actually, even though it's up here and we integrate HTTP into HTTPS and then we use Secure Socket, that's actually a layer 4 technology. So they mention SSL up here and transport layer security. We do configure it, and it is talked about at the access layer, but the actual technology of moving that data securely actually happens down here at layer 4. So it's actually interesting that whoever chose, again, Martin, who chose to make this, he put it up here where it doesn't really work there from a actual where the rubber meets the road side of things. They're set, secure electronic transmission. It's authentication for credit cards and that stuff. It's been overtaken. We do everything over SSL now, guys, right? Even FTP, we use FTPS and all that kind of stuff, right? FTP and TFTP, we don't use these a lot because these tend to be insecure protocols, but you might have noticed I run TFTP in my home lab. And you say, wait, are you running home? Yeah, TFTP is part of Warewulf. So when I was just in Warewulf here, just a little while ago, when you set up your Warewulf server, one of the things you can set up is where are we doing TFTP boot? And then where does our iPixie come in for our systems to be able to Pixie boot? So this is one of these things, right? Like, and this is the thing. This is not a secure protocol. It's on port 69, which is useful to know. It's no authentication, so it is considered insecure. But if you're in an air-gapped environment and you have a security posture that allows it, this is okay. I'm going to tell you, if you're in an organization that's very modern and does what we call zero trust security, you can't use this. TFTP is out. FTP is out. Telnet is out. The only reason most of us use Telnet, like the only reason I know any systems engineers that have used Telnet in the last 15 years is just to test if a port's open, right? Like I come here and I'm on my machine here, right? Back over here, and I want to see Telnet. Do I have Telnet on here? I don't even have Telnet on this box. I'd have to install it. But then I would take Telnet and I would make sure it would be a lot like Netcat. On Hostbox, can I get to 2049, which is my connection, right? And that might not work, so then I do something like -VZ or something that it just oh, whoops. Okay, you're not gonna let me do that. But it says, oh yeah, look, I connected on that port. And then see, this is one of the hassles about it. So then you do like something like this, timeout like 3, and then you can just see Netcat not connect. But I actually did connect, right? And I had an open connection to 2049, which by the way was trying to establish an NFS connection. But yeah, certain machines in your data center and Big Corp Bloomberg, it was crazy. Yeah, I can see. I wouldn't connect and I wouldn't do configuration over it, but just to see like is a connection open, because you know how many times this has helped me over the years where I want to make sure, like let's say I'm just some engineer in my company doing Linux, and over here I've got my jump box, and my jump box needs to talk to Hostbox for NFS shares, right? I want to mount NFS off of it. In fact, I think I am mounting NFS off of it. Oh, maybe I'm not. I thought I was. Some of my other boxes mount NFS off of Hostbox, that's for sure. But let's say I wanted to mount NFS, but then I set up all my stuff over here, and then over on Hostbox, like I can SSH to Hostbox, right? I can see show mount -E. I can see that those things are being shared out to anybody. There's no security at all in this lab. My lab can do whatever it wants, right? And then I bounce back over here, and I can't connect, let's say. Well, now, because again, I'm just an administrator on the Linux side of things, guys. I'm not the network engineer anymore. I haven't done network engineering professionally in quite some time. I left that in about 2013. I was already doing a lot of Linux stuff, but I got out of networking full time. It's funny, I still end up doing it a lot with my high performance compute clusters, but I try to stay out of, just strictly speaking, all networking. Anyways, where I'm going with that is, look at this. I would now know I need to contact someone on the network team because we got a firewall. We got something in the way. We got something blocking the access between here and there that I do not have control of anymore. Telnet is hanging on without getting connected to target server. What could be the reason? Yeah, it's typically there's a firewall or something in the way, PowerSpan. Like if I can ping it, so if I can ping the box, ping is ICMP, so that's over here at layer 3. right? That's ICMP hitting the box. I know that it's there. I know I have a connection to it. But then if I can't use one of these other ports and I can't hit it on a certain port, there's something else in between there that's not visible to me on the system, right? We only have the tools we have to see the things we have. So we SSH over, which means that we connected from this box to that box on port 22. So 22's working. I know that it's allowing things to mount, and I can see things are right, exposed. They're exported. So we can see those things if we could connect, but now we can't get the connection. Something in there is busted in between there. All right, so there's that. You got SMTP, Simple Mail Transfer Protocol. That's port 25, email queuing and all that good stuff. And then SNMP, which is your Simple Networking Management Protocol. And some people call it monitoring because management, it is management, by the way. Management's the correct word there. However, you really shouldn't do managing over SNMP. We abandoned that 20 plus years ago. We normally just use it for scanning and monitoring things in the network. We send out alerts from devices that are called traps. That's true. And then we use MIBs, Management Information Bases, to connect things. Then there's this whole path called OID. And if you want to, it's an organizational identifier. If you want to go dig into how MIBs are called in SNMP walk works, that might actually be a good lab. You know what? Hold on. That might be a really good lab for me to put together. Let me put that on here as I know a lot of these haven't been done, even though I've been putting it on here. But SNMP between control plane and node 01 setup. Let's just do it like this. Setup, and then SNMP walk. And then there's some security considerations. There are 3 viable type. Well, okay. There's only one viable type of SNMP that you're going to be allowed to use in your company. But there is SNMP version 1, which is insecure in every way, and you do not use it. There's SNMP version 2C, which is also, it works, but the configuration data and the connection string is not secured. So most of us still don't do it. And then SNMP version 3 is really the only one that you should be able to get away with in your organization. Like your security team will probably come down and smack your hands. If you ever turn on a device and you see that it says SNMP version 1, do not leave that running, right? Don't leave that in your organization. Sinbleed, hopefully this stuff's useful to you. Thanks for the follow. SNMP at Microsoft is termed as security, not my problem. That's actually funny. I like that. All right. Okay. Then we drop down to presentation layer. Presentation layer. There's 3 things that happen at the presentation layer. They're talking about different compression and encryption, decryption, but there's 3 things that happens at the presentation layer. They happen on one side and they unhappen on the other side. Let me show you this. Back to this again for a second. They are over here. We encrypt, we encode, and we compress. Those are 3 things we do here. We encrypt, we encode, and we compress. Over here, we decrypt, we decode, and we decompress. And you say, what the hell is this guy talking about? Well, look at the protocols. The protocols that exist here are standards like JPEG, all of your MPEGs, all of your call-based codecs exist up here. TIFF, which is that's like an architectural drawing thing. All of your things that do any kind of encoding, encryption, and compression of the actual data that you're dealing with, right? So your ANSI and your EBCDIC type lettering and numbering, that all happens up here, right? They talk about a technology up here might be a gateway and then messages. Presentation layer tends to just be all of those things. Yep. So there you go. Yep. And then down here at the session layer is going to be most of the inter-host communication. And all I ever deal with in here is what we call the sliding window, right? The window of where things are. SSL and TLS belong down at layer 4. I should send this guy an email and tell him some of this stuff's way off. But anyways, password authentication protocol, point-to-point tunneling protocol, RPC, remote procedure call. Sure. NFS is still up at layer 7. That's fine. We're not really too worried about it, but that's your network file sharing, right? Session layer is the windowing that is part of the transport layer. As the transport layer has standard, what we call connection-oriented protocols in some cases, those ones are going to have a window of how much you can send before you get an acknowledgement, and the session layer is what handles that. But up here, there's two things you really need to know at the transport layer. There are connection-oriented protocols and there are connectionless protocols. Even though it's called TCP/IP, it's actually TCP/IP is a suite of protocols, and at the network layer you have TCP and UDP. They are the two kings here. They are everything is TCP or UDP at layer 4. TCP is a connection-oriented protocol where everything is established as a connection. All the data flows in an orderly manner, and then after we're done, we break down the communication. UDP is exactly not that. UDP is just shotgunning data over as fast as it can. And there's some pretty good memes online of like TCP is like handing a baby to your friend, and UDP is like shooting the baby like a basketball at the person. You know, you're like launching the baby up, launching them like a basketball or whatever. Anyway, so TCP has three-way handshake. There's the SYN, the SYN-ACK, and the ACK. And you can see this. If you go actually look, if you pull up your own little Wireshark, this is for people that want to get better at this stuff. You've got to go spend time inside of this. Wait, what are you asking? Wait, isn't TCP and UDP transport layer ensuring process to ensure communication which kernel manages via FD? Sure. TCP is connection oriented and UDP is not. I can tell you that for sure. But anyways, let's go look at one of these real quick. Let's go to just one of these. Was one of my Cali ones from, I don't know, last year sometime, right? And we can come to any of these TCP sessions that we have here, and we can go look at how TCP is doing what it's doing. It's got its source and its destination port. I know that the destination port is port 22, so this was an SSH connection. I know that right off. And then the 34618 is my client port on my machine that the system was going to send data back to, right? But then we come down here, and as this TCP connection is going, there are sequence numbers that are always incremented and acknowledgement numbers that are always incremented and sent back after a certain number of packets are sent. Well, at this layer, it's streams still, but after a certain amount of streams are sent, and that is determined, again, by the sliding window at the session layer, layer 5, right? But anyways, back up here, that's all TCP stuff. UDP just launches everything over. It just yeets it over the wall. And really, what we talk about here with the idea is less overhead. Because, real quick, let's have a quick phone conversation. Let's say that I was going to talk to you on the phone, and we were going to use something like TCP, and I would say something like this. I'd be like, hey, how's it going? And then I say, hey, can you acknowledge how it's going so that I can continue? Can you acknowledge that I just said? Right, with TCP, I've got to wait. I can say a certain amount of syllables, let's say, before I have to sit there and be like, hey, are you listening? Like, and I don't even say that. Like, I actually just wait for you to acknowledge, right? But whereas with UDP, we can just launch data over. So it actually, this is one of these things where it's non-intuitive, because I always ask my college students, and I'll ask you guys the same thing. Do you think like this multicast that I'm using to talk to you guys, and then like when we're in, we're some type of calls or meetings or whatever we're doing, do you think that's TCP or UDP? What do you guys think that is, right? What do you think you're using there to have a communication and like a web meeting and that kind of stuff, right? It's all UDP. It's all UDP. The UDP is just fast, and we shoot the data over, and we do something else to reconstruct the data. Typically something like real-time transport protocol, RTP, which stands for real-time transport protocol. Isn't that funny? And then SRTP is secure real-time transport protocol. And you can see that, by the way, here. I've got some calls that I think I have. No, I don't have any SRTP in here, but I have some. If we open this one, here's some RTP, real-time transport protocol, and then we can look at this and we can break down what was happening here. But you'll notice that the underlying protocol is the UDP, right? And you guys have the capability You guys have the capability to come in and monitor all this stuff, like a tool like Wireshark, which used to be Ethereal. You can come in here and I could actually turn this on and watch my network right now while I'm talking to you guys. And then we can go evaluate what's happening in my information. We can use, so SIP is your session initiation protocol, and SIP has this method of how we call and respond back between phone calls. So SIP is part of our, if we're doing like web calls, like web phone type stuff, right? So we've got all these tools here that use this, but that's all UDP. TCP is much more regimented, and there's a lot more overhead. Let me just show you here real quick. Again, we're not spending a lot of time here, but in the TCP UDP part, here is the header for TCP, and across here is 32 bits. So there's 32 bits across there. There's your first octet, your second octet. Here's your first octet. Here's your second octet. There's your third octet, and there's your fourth octet. So that is 24 bits, another 24, another 24, another 24. So you have, a little under 100 bits here as a header for TCP, right? Now, just even if I didn't tell you all that other stuff where we have to have these sequences and acknowledgments going, and everything has to be acknowledged in order, and all those other things, let's just look at the size of this compared to a UDP header. This is UDP right here. So that's 1, 2. So that's again, that's 4 bytes across, because it's 8 bits, 8 bits, 8 bits, and 8 bits. And then it's this. So that is right there. That is 32. That is a total of 64 bits on the front. Up here is nearly 200 bits on the front. Again, not even dealing with all the shaking of hands beforehand and all these other things. And then I always give you guys, if you want to go read the IETF, the RFCs for things, they're excellent material for digging in as an engineer, but they're also excellent material for if you have trouble sleeping. If you tell me, hey Scott, I have a hard time sleeping, I'll tell you, you know what? Go read some RFCs every night. Put down your phone for 20 minutes before you go to bed and read some RFCs and tell me if those things don't put you to sleep. But also tell me that you don't know networking a lot better. Because look at these. I mean, if you've never seen an RFC, one, if you tell me, Scott, I want to be an engineer, then I would tell you got to spend some time with RFCs. You do. You have to get. Now, you don't have to be religious about reading them, but you need to, especially when you first kind of start. You got to spend some time in here and understand this is how transmission control protocol works right here. Fisherman, yeah, I agree. Puts you right out. But here's all of the pieces about how these things work, and then once you understand how these things work, then you can go start messing around with them. What is this? Oh, this was us doing that authentication stuff earlier because we were having Apache guacamole issues, right? So, TCP header, UDP header. You don't need to memorize them, but you need to understand what's kind of going on with them. All right, where was I at? Oh, we were back on this. Back, we were here. Ranger check, Ranger's still not in bed, and then we were doing this stuff. Fisherman gave a tier 1 sub. Nice, thank you. And Sinbleed, if this helps you out so you don't have to watch the ads, make sure you refresh your browser. Just remember, I thought I work as a kernel dev, and I remember to learn the hard way to read the protocol impl in the kernel, followed by the RFC, for example, with UDP and kernel. Yeah, Sinbleed, I have no doubt that people that work with the kernel probably spend a good amount of time looking at like implementation of stuff. Let me pull this up for a second. One of the things that as you guys look at these, right? If you knew nothing else about this, you might go, oh wow, that's some interesting little bits right there. What are these little bits all doing? And we could go read again the RFC and figure it out. But I can just tell you that these are the bits that set whether it's the SYN or the SYN ACK or just the ACK. So you set this bit on when you want to do a SYN, and you set this bit and this bit when you want to do a SYN ACK, and you do this when it's an ACK. And then you can set urgent, and you can also send push and reset and then fin, and then you can have fin and FINAC when you want to turn off a connection, right? But what we talk about, if you've ever heard somebody, so this is one of these things where it starts to get into a little bit of the lore, but this is still valuable, I think, as systems engineers. If you've ever heard somebody call a packet a Christmas tree. They're like, it was a Christmas tree frame or a Christmas tree segment. Most of the time you'll hear it as a Christmas tree packet. They're talking actually at the segment layer, and they're talking about all of these are lit up like a Christmas tree. That's where the term comes from. So have you ever heard that? Like it's a Christmas tree attack or something like that? It means that all of the bits for this are lit up. Another way to learn, Nmap plays with stealthy if a port is open. Yeah, Nmap has a bunch of different tools for sure. And I think there's some value there for people to scan between systems and know how they work. Fisherman's giving away his money. Yeah. Fisherman's also the one, Robodon, if you know, Fisherman's the one that sent me that really nice knife. So now all of you are, people part of the professional Linux users group. You guys are all trying to work on who's going to be my favorite, but you're all going for number 2 because Fisherman's already my favorite. So I'm just kidding. All right. He's actually a bane of my existence. But anyways, we get down to network layer, right? And most network engineers operate at 4 and below. They don't really care that much about anything above this. In fact, I joke around, but it's true. At the layer 3 with packets, if I can ping a device, I just hang up on you. You know, if I can ping over to some other device, right? Like you call me on the phone and you say, Scott, hostbox is down, and I say ping hostbox. I just hang up on you because I got a connection. Yeah, Robodom, you're my favorite. Our addressing that happens here, IP uses, so we use our IPv4 and IPv6. IPv4 is a 32-bit addressing scheme. IPv6 is 128 bits. 128 bits are way bigger than 4 times bigger. It's just a 4 times bigger address space, but the addressable number of bits is actually trillions and trillions of times bigger, right? In fact, if you were to go look at it, if you wanted to look at it, you would do it like this. You would go here to Google's. You just go to the normal Google's, and you would say 2 raised to the 32nd, and you would get like 4.3 billion. And it would express it like this. That's about almost 4.3 billion, right? There's your hundreds, there's your thousands, there's your millions, and there's your billion. Boom. But then you change that over to 128. And now 128, man, that's a number right there that they have to express in what we call scientific notation, right? And you guys all know how scientific notation works, right? We take this 38 right here, and we go 1, 2, 3, 4, 5, 6, 7, and then we start adding zeros, 8, 9, 10, 11, 12, 31 more times to get the number that is something like hundreds of trillions times hundreds of trillions is what this number ends up being. This number is so big that every molecule in the known universe fits into this number. I don't know if you guys know that. But before I say we should never run out of these addresses, let me tell you, we thought we were never going to run out of the 4.3 billion, right? That's why we had to do so many natting and all those other things. But anyways, that's how you find out how addressing works. Fragmentation. IP will subdivide a packet if the size is greater than the maximum allowed on the network. I've shown you guys this before, and let me ask you this right now, and I'm going to take the first thing, like my college, when I teach my college students, I'll take the first thing I hear. Do you guys want to see fragmentation happen in the real world? Fragmentation is huge. It is a huge concept for bypassing firewalls. It's one of the first things you need to learn if you want to bypass firewalls, right? If you tell me, hey guys, I'm going to be a red team guy and rubber meets the road stuff, I need to, oh yeah, there's tools that'll do your fragmentation for you, but I'm saying you have to understand what it is. Do you guys want to see fragmentation from like just a normal Linux box? Do you guys want to see that? And do you want me to prove to you that it's happening? All right, we could do that. I'm going to go with the first thing I see on either YouTube or Twitch side. Message routing, error detection, we've got all these different things. So these are what we call our routing protocols. All right, Robodom wants to see it, so we're going to do it. Our routing protocols are protocols that tell the network things about the network, right? So these are not all routing protocols. IP happens to just be the protocol that deals with the addressing and all that kind of stuff. IPsec deals with, there's 2 types of ways that we can do IPsec or IPsec. They are tunneled mode and header mode, I think, is the 2 types. And they deal with whether or not you encrypt the header or not. ICMP is your Internet Control Messaging Protocol, which is where we get ping from. Ping is your packet internetworking groper, right? Hopefully I'm throwing a lot of terms at you guys that, you probably have heard, but maybe never really messed with much, right? Then you got Border Gateway Protocol, Open Shortest Path First, Route Information Protocol. And these are the two, like, this is the crux of, like, your Cisco stuff if you're doing Cisco. You get to BGP later on, but when you first start Cisco, you've got your distance vector, which only deals with hop counts. And then you've got your Open Shortest Path First, which are what we call a link state routing protocol. And they deal with the metrics of the quality of the link and how they're going to send things, but they also deal with topology changes in the network. So Open Shortest Path First is going to be one that only makes changes when topologies change. RIP is going to make updates all the time. RIP is going to have a hard hop count of like 16, and then you get to like RIP version 2, and with RIP version 2 you can handle IPv6 and some of these other things, right? Then you get to Boot P. Boot P was, man, poor Boot P. It doesn't exist. It does exist, but it's kind of like the little stepchild of DHCP. Boot P is the predecessor of DHCP, and DHCP is Dynamic Host Configuration Protocol, which actually sits between Layer 3 and Layer 2. And you say, well, how do you know that, Scott? Because when a box first comes up, to be able to communicate to DHCP, it doesn't have an IP address. So how does it communicate to find the device on the network? Well, what it does typically is it broadcasts all Fs in its MAC. So it sends a MAC broadcast to everything, and if it finds a DHCP server, the DHCP server responds and says, hey buddy, here's your IP address. Go about your day. And then the system configures itself and all that good stuff. Then there's some other ones. These are mostly old. Geez, most of these are older. But anyways, they've got what they are down here. So man, I just hit all the major pieces of them, but you can read more about them if you want to. Here's the packet stuff. So we're on a Linux box, right? And I you can ping to -c1 to www.yahoo.com. We're using Yahoo for a reason. If you start sending weird packets to Google, it stops responding. So that's actually kind of funny. But I'm going to ping -c1 to Yahoo, and that's going to connect. And then I'm going to do a ping dash with an S. Then I'm going to say the size that I want to use is 1500 bytes. And when I do that, it's going to say that it went ahead and pinged over there and it connected. But there's something that happened here. Something that it's hiding and it's not even telling me about. I don't want to say it's lying to me, because it's not. It's just not really telling me about it. Is that if I were to do a -M here, whoops, -M, and I said do, we are going to set the do not fragment bit. So we are going to set, so M is for permutation, and we're going to say do set the do not fragment bit. It's weird, I know. And when I do this and try to send a 1500 byte packet, it's going to say the message is too long. But why did it work earlier when the message was also too long? Well, because what happened, without you knowing, is this packet right here was chopped up into 2 frames right here. It was chopped into 2 frames. So at the MAC, at the data link layer, right, the media access control, said, hey, that's too big to come through. I'm going to chop it in half. But then I tried to do the same thing, and I said, this is a very, very important packet. Do not chop it in half. And when I say do not chop it in half, it cannot. And then now we've got a problem. But watch this. I'll drop that down. We did this the other day, so go to like 1460, right? And that'll go right through. Why? Because 1460, with the header and footer that are going to be added by an Ethernet 2 frame, are still going to be smaller than the 1500 bytes, right? Because 1500, if you do an IP adder, your default, here's your maximum transmission unit, is 1500 bytes. Yeah. And this is huge. How this data flows in the network is huge for how firewalls inspect it. It's huge for how payloads get reconstructed on the far side. It is a primary technique nowadays still. I think I told you guys when I worked at AAA, I went and I ran the red team, right? So I was doing all of the offensive security for the company, and one of the things that happened to fall on us was our web application firewall, and I had to run the web application firewall and all of our certificates and stuff, right? And this was part of how people try to exfiltrate. It's part of how they try to infiltrate your devices too. They try to figure out how we can get data past, and then the payload on the other side. Yep, payload gets reconstructed on the far side. It doesn't matter if it's all in pieces. And I'm trying to think of like a good example of that, in like a, like in a movie or something where they like took a robot apart and then like wheeled it in and then put it together when it got inside or something. Like one of those type of things, or it's this idea of like we can the far end's going to reconstruct it because that's what the rules say to do. So it's just people playing around because they read the RFC and understand the rules, right? So that's down at data link. Data link is where we're dealing with frames. By the way, if we go back here for a second, the data link layer is the first time in all of this that a trailer is applied. There's been headers applied as we got down into segments and packets and frames. There's always a header applied, but only at the data link layer do we have a trailer applied. Only there. And the trailer is a checksum. There is a FCS, a frame check sequence, that looks at everything in the header from the start all the way to the end and says, yeah, this is good. This is good. It is good when it gets to whatever device that we're doing. And typically there's 3 ways that switches work at the... Oh, hold on. I got to change this. That music was terrible. That was enough of that. All right. And press kill. Hopefully this stuff's useful to you. Thanks for the follow. Let's jump back out of here. There's guys. By the way, if you're like, hey, Scott's not talking about this right now, I have a whole YouTube video on this stuff. Right. This is a primer. It's on YouTube if you guys want to go watch that sometime. We're talking security of this stuff, and then there's ARP and RARP down here, which kind of sounds like. Has anybody here ever watched one of my favorite movies? Is Hot Fuzz. Hot Fuzz is such a good movie. Thanks for the follow, Doomus FPS. Hopefully this stuff's useful to you. But there's a movie called Hot Fuzz, and the guy's always like, yarp? And then they ask him, like, no, and something that's negative, and he goes, narp? Anyways, it's kind of a funny scene. But address resolution protocol is how your devices know who else is on the network with it. Man, I love Hot Fuzz. I think it's a masterpiece in how every joke comes back around by the end. Let's look at this. I have ARP on this machine. Here's all my devices. Here's the devices and how they're mapped to some address. Some things are only IP addresses. Some are by names and how my system knows them. These are mapped names inside of my Etsy hosts. And then look at this. I could pull up in a Windows box, right? Like this is a common protocol. This is not like you don't have to be on an all Linux system. We could be on a Windows box. ARP-A. Give me everything. Show me everything my system knows about. And by the way, a bunch of these devices in here, a bunch of these are devices that my system knows about locally. And then there's devices out in the world that it's also talking to, right? Different internet addresses and stuff. Yeah, DHCP and ARP make a LAN work. Yeah. Guys, I had an ARP problem in a cluster just the other day. We added we were running a cluster. So there's a thing. Actually, I got to make a post for one of my college classes, so I need to look this up. But have you guys all seen the what's it called? It's the there's a very common like technology adoption curve that's been around for a while. There's a bunch of different ways that people look at it. Let's grab any one of these. I'll just go to images. This is the technology adoption curve right here. This looks like a pretty good one. Somebody put this together. But you've got innovators, and they're the people that start using technologies like right away. And then you've got your early adopters, and there's this thing called like the chasm here, right? Then you got your early majority, and then your late. Well, so companies that are risk averse. Companies that don't do, like, this over here is going to be your really fast movers and your, what are those guys called? The, I don't want to call them like the Silicon Valley types, but like the startups and stuff spend a lot of time over here really using a lot of new technology, right? But I've worked a lot in my career on high performance compute. And high performance compute hangs out back here. They want stability. They don't want new shit that's waiting for, oh yeah, it's GA, but man, you're waiting for new features, and features and bugs are the same damn thing over here. Yeah, we're hanging out back here, guys. This is the majority of people using technology right here, right? You start talking about standard deviations and stuff off of a mean. This is a standard distribution curve. It tends to fall into a standard distribution. I spent most of my career back here. I tell you guys, like, one of the things about working in tech is you don't always get to do the coolest thing. Sometimes your job is just to stand up 100 freaking web servers that look exactly the same behind a load balancer. Guys, you know how many times I've had to do exactly that thing in my career? I used to work for GoDaddy. You know how many times I've done that exact task right there? Right? Making 100 servers look exactly the same behind something. And, you know, I automate it, right? That's one of my strengths is automation. But I hang out back here a lot. And a lot of government systems hang out back here. Anyways, where I'm about to go with that is we were on 7.9 of Red Hat. 7.9 is almost end of life. And we were moving up to RHEL 8. We were going to 8.8. And we put 8.8 into our cluster. And 8.8 was touching, so it was touching a InfiniBand. So we had Mellanox drivers, and I did all that. And got us all connected. And then what was happening was this little thing. And this actually, this like crushed our system. Was right here with ARP. The newer way that ARP was working inside of the, so if you ever run, let me show you guys real quick. If you run a, so I'm on a CentOS 7 box, right? I am on a 3.10 kernel. You guys know the kernel's up at like 6 now or something, right? But if you jump over to a, do I have an 8 box? I think I have an 8 box in this environment still. Let's see if we have them still. I'm pretty sure I had an 8 box in the environment. Let's see. Oh, is he still here? I think this box is still up. Hold on. Yeah, he's not commented out, so he should be up. Did I turn him off? Hold on. Well, anyways, where I'm going with this is the way that that box, the Red Hat 8 box, has handled ARP actually brought our InfiniBand network to its knees. Yeah, Sinbleed, I'm glad you were here hanging out. Yeah. So this is all fun stuff, right? But the way that ARP was working was it was like going over 2048, you know, and this has to do with the way that the system works, right? This newer version of OS, and it was crushing our InfiniBand network with ARP requests. And it was actually taking, when those devices were trying to like just make a file system in our GPFS, it was bringing that system to its knees for 5 to 10 minutes at a time. That we have thousands of researchers, thousands of people doing like what net was over $1 billion a year worth of research. Now we could break $1 billion down and divide that by 365, but I can assure you it's a lot of money per minute, right? And we were like crushing the system by these simple little like make dir requests. It was bad. Yeah, Sinbley, it was really good having you back around hanging out. Hopefully this stuff's all useful too. Yeah, and hopefully this stuff's fun too. I mean, the goal isn't to make this stuff fun; it's to make it useful. But if it can be useful as well, that's good as well. But yeah, anyways, the point is we were back here and we were going from like here to here. And we still crushed the system, even though we were a heavily risk-averse company. And we were trying to do, we're doing research. We're doing big data research and stuff within a high-performance compute cluster, right? So we weren't trying to be top-of-the-line stuff. Anyways, you got your Mac. The OSI model took the data link layer and said that's going to be layer 2, right? This is a 7-layer model, right? Application, it's our application, our presentation, our session, our transport, our network, our data link, and then our physical. But our data link layer almost got split into 2. So you guys don't know. Yeah, ISOBU. It's because of what ARP was doing. ARP was trying to walk every device in the GPFS cluster every time, and it was crushing it. It was taking our network down with ARP requests. Yeah, yeah, and they found it because we had Grafana running, and we were just watching the Grafana network as this would happen, and we just happened to go like, well, what the hell's going on with this ARP? And anyway, so where I want to show you guys is there's two things that almost got broken out: the logical link control and the media access control, because the logical link control comes from above, and it's how we break out the access from the kernel and from the upper layers. And then your Mac, your media access control, deals with your talking down into your actual data link layer. So your data link, your physical layer. So your data link layer almost got broken up into a LLC and a Mac layer. We would have had an 8-layer model. And some people do teach it with these being distinct layers because it helps, right? Helps to think about. And then you got ARP and RARP, and you can read about those. And then physical layer, again, physical layer is our physical signaling. It's ones and zeros. There's bits. It's voltages or photons across a light beam. We've got electrical hardware and drivers at this level. It just sends and receives bits. That's all it does. Physical layer is repeaters as well. So things that strengthen signals and clean signals. You have two major types of signaling. You've got analog signaling and digital signaling. If I were to draw them, let's get out of here. Let's just go here, and I'll draw them real quick. An analog signal looks like this. It is a perfect, continuous sine wave. I know that's not perfect or continuous, but deal with it. Digital looks like this. And based on time, this can be a 1 or a 0, or the shift between them can be a 1 or a 0. And we can have non-return to 0 codes where this can be 0 and this can be like positive 5 voltage, or this can be non-return to 0, so it can be positive and negative voltage. And there's all kinds of things that can happen here. But if you guys have ever been through one of my talks, and if you guys have ever heard me talk, you know, to my engineering group, right? So when I'm talking strictly to the professional Linux users group, I talk very, very generally about things that are very true. And this is the simple communication model. And I will make the same challenge that I have made to thousands of college students and many hundreds of engineers over the years that I've trained and talked with. There are 5 things that must be there for communication to occur. There is no model known to man that is smaller that is still functional. Whether it be 2 ants talking to each other with chemicals or us talking to a rocket, it doesn't matter. You've got a sender, a receiver, a message, a medium, and noise, right? So when we talk about this, and this is the simplest model that works, then there's a thing called the effective communication model where we add a feedback loop. But there's 5 pieces. A sender encodes a message to be passed across a medium where it's affected by noise until it's received by the receiver and it is decoded. The process of encoding and decoding is always done in networking by what we call a protocol. And the protocol is a set of rules that govern communication. That's it. That's it, right? That's it. Super simple. You can say, hey, Scott taught me something today, right? Boom, there we go. Well, so come back here real quick and back to this. And I want to show you something about this. If a continuous perfect wave like this weakens, there's always a tool, there's always a thing happening. Attenuation. Attenuation is the weakening of a signal as it propagates through a medium of some type, right? So this signal is going to get weaker. This analog signal is going to get weaker. So what we're going to do is it's going to come into a repeater, and we're going to take it, and it's been affected by noise as it's weakening. So it's got this little noise, right? So the signal was big and strong, and then it started to get weaker and weaker and weaker like this, but it was also being affected by noise. So when we get to a repeater and it goes to come out again, we're going to amplify the noise into the signal, and over time that perfect signal is going to become degraded. I'm trying to write way over to the right of my thing. But a digital signal, if a digital signal's flowing along and it starts to get affected by noise, right? And then it hits a repeater, and that repeater is a digital repeater. The digital repeater cleans the signal perfectly back to the digital flow, and that can happen as many times as you have repeaters where you don't have some type of thing. Now, you'll experience delay. You will still experience degradation of signal, but you will have a 100% clean signal at the far side. Is anybody, I don't know if anybody here is willing to admit it. I'm willing to admit it. But in the 80s, there used to be these commercials there were these commercials when I was a kid from Sprint. And Sprint used to say, Sprint is a big phone company, and they would say, it's so clear you can hear a pin drop. And on the phone call, you'd hear a guy call from like New York to California, and then you would see a pin drop and hit his desk, and the guy would hear it like across the line. And that was because they were using digital signaling, and they were cleaning the signal the entire path. So on the far side, it was completely clean back to whatever the sampling rate was. We're not going to get into sampling rate right now. But analog signals get weaker and degrade over time. No matter how many times you try to pick them up and brush them off, they are getting dirtier and dirtier. They are getting more affected by noise, no matter how many. And you can do some techniques to try to clean signals up pretty good, but it is never the perfect, pristine signal that is coming out. My voice right now is analog. My voice is analog, but it hits my little Blue Yeti microphone, and it is immediately digital, all the way till it gets to your side, wherever you guys are sitting, whatever you're listening on, and then it becomes analog again. But it's digital clean all the way to the end, so there is no loss of signal. There's nothing really lost in my voice except for the sampling rate. There's a certain amount of, we can only get so much back. We're not going to go into sampling right now, but the sampling rate is how we sample things down, and how much we sample that is how clear my voice comes back out of the side. You're not actually hearing this from me. This is how my voice is sounding. It is a perfect wave. My voice, even though it's whatever it is perfect for what it is. But we sample it down digitally, and we actually send this. So you're hearing my voice as this. It is a bunch of samples carved out of the original wave, but they are perfectly clean when they get over there. So it's not. So if you ever have a friend that tells you, I can tell the difference, like if you have a friend that's like you might think they're a snob and they listen to only analog, they want the old recorded albums, and they're like, I can hear the difference. There are people that can hear the difference. Yeah. Fishman would have something to say about the perfect voice. Sure. All right. So anyways, that's a thing there. Let's go back to where we were at. I don't have much time, I don't think. I think the wife's going to come looking for me soon. But there's more about the network layers here and stuff. And then let's go down here. We talked about all this. Let's talk about, this is the application presentation session. We could zoom in on that, but I think it's kind of hard to read that. But this is some of that same stuff that's just kind of broken down from there. All right. They talk about security modes, and here's all the wireless spectrum, right? 802.11 is an IEEE standard, and it's actually fun if you guys want to hear some Deckard Cain stuff. Who knows who Deckard Cain is, right? Some of you guys know. Deckard Cain, here you go. IEEE, does anybody know where the number 80, as I gave part of it away, 802 comes from? It is when IEEE met in February of 1980. That's where 802 comes from. So if you're wondering about that, when they met to do the standard and build these standards for the 802.3, 802.5, 802.11, the original standards body convened in February of 1980. That's where 802 comes from. And then there's all these different speeds and things that come up, and then we have all these different frequency hopping spread spectrum, direct spread spectrum, orthogonal frequency division, multiplexing. There should be an M on the end of it. Direct signal spread spectrum, right? All these things, all these different ranges and ways that these things talk with each other over here, right? You don't need to know all of that in any way. And then, so a thing to note, they talk about security enhancement protocols. There was a lot of stuff that was built to just simply work. The original protocols were not built with security in mind. That probably is very obvious to people that care about security. Jose Sosa said, I didn't know something like ARP would change across software updates. It absolutely does between the different versions of the kernel, yeah. The way that they handled ARP. Yeah, that hammered that big project I was working on. It didn't affect us that much. We found it within a day or two. But it was right at the end of a big downtime where we had a planned outage and we were working on moving up to a newer version. And we found it before it became a major problem in the environment. So, security enhancement, the protocols were, again, just designed to work, so we had to add things later. At the IP level, we added IPsec, which is a shunt. It is not built into IP in any way, and IPsec was something that was added later. And then now with IPv6, a lot of those things are built in and you can add pieces of security modularly yourself if you want, right? It's based on the protocol. We've got different types of firewalls. I've shown you guys a lot of firewall stuff, but you've got packet filtering firewalls, which tend to be at layer 3 and 4. You've got SPI, stateful packet inspection, or stateful packet filtering firewalls up to layer 7. You've got application proxy firewalls and web application firewalls, WAFs, that operate at layer 7. And they actually understand how the traffic's supposed to flow. And then you got circuit level proxy. And actually you have another type. Yeah, you got static packet firewall. You got all these different types of firewalls that are doing things at all these different layers. Some are more or less aware of the different things. If you're dealing with WAF, web application firewalls, or application proxy firewalls up at layer 7, you can have things that understand, the way a header is, the way that traffic's supposed to come in, and they can actually be looking at API payloads and stuff. I tell you guys a story sometimes where, when we're down here, when I was running the web application firewall for a big company, one of the things that happens is it watches for SQL injection. And we were getting past a good API call from a company we trusted, but some of the things that were coming in looked like SQL injection. So they were actually getting blocked by our WAF, and we found it. And we're like, wait a minute, why is this getting blocked? But what happened was they were passing us the names of people that were trying to pay us, right? We were dealing with banks. So think about the banks that you've heard the names of over the years. Have you ever heard, tell me if you've ever heard any of these, like Select First, or, Western Union, or Select First Union, or any of those names. If you've ever heard any of those, like, they love calling banks unions. They love calling banks Select First, or Select, I don't know, just a bunch of things. But all those words, if you've ever heard SQL, you said, select. That's how you read stuff out of a database. And union, that's how we join things out of a database, right? Like, we have all this stuff that looked like, and so these names were coming in that were real names, and they were valid names, right? But they looked like SQL injection to our web application firewall, so we had to allow that. It did cause problems, Robodon, but thankfully that only came like once every few weeks or something like that, and we found it pretty quickly when it happened because we weren't getting the data that we expected. But we had to go dig into the firewall logs to find, and we were using a third-party. There's a very popular third-party firewall. There's the AWS web application firewall for people up in the cloud, but there's also a second really big firewall company out there called Akamai. You guys may hear about Akamai in your career. You may deal with them. So anyways, there's that. We keep coming down. You need to know your IPv4 network classes at a high level. Class A is between 1 and 127 in the first octet. Class B is 128 to 191. Class C is 192 to 223. Then there's two other ones that aren't really talked about much, but D is 224 to 239, and that's a Class D network, which is our multicast. And then Class E, which is experimental, is 240 and above. 240 in the first octet and above. I don't think you're going to need to know ISDN, but man, I learned ISDN when I first did my CCNA. And you had your BRI, which was your 64 kilobits per second with a 16. So you had two BRI channels and then a 16 kilobit D channel on a normal system. and then the 16 kilobit was a control channel. So you would send control information over this, and then your typical ISDN would have 2 B channels and 1 D channel. So it would be 2 B channels, which would be 128 kilobits, and then you would get the 16 on top of that. So what would that be? 144, right? So yeah, so your normal BRI was 144 kilobits per second. You don't need to know that kind of crap for these, but man, that brings me back. PRI was 20-something B channels at 64 kilobits per second, and then there was 1 D channel, or 2 D channels, I think, for 64. And then the PRI was a lot higher, but you paid a lot more for that. Look, oh, there's attenuation, right? The decrease in the signal strength. They've got all that kind of stuff. And then this is just information that you need to know. Types of wireless network, right? Ad hoc mode. You can still set ad hoc mode up and just connect your devices to each other. Probably don't do that too much. Infrastructure mode, where you connect to your devices. And then you got standalone, which is just an isolated system. Oh, Rilma, you can download this. I linked it a little while ago. You just go to Google and just say Sunflower CISSP doc. That's the first thing. Here it is. Yeah, so if you're studying for your CISSP, this is a good one. I'll put it over on the YouTube side. We're just going through, his doc here. You've got your WEP, don't use wired equivalency policy, but it's been cracked since the early 2000s. WPA2 is typically the standard nowadays. And you don't need to memorize a lot of these terms, but it's a good idea to know what they are, right? All your TCP ports, you need to at least know typically that the first 0 to 1023 are your well-known ports, and they have some here that you should probably know, where they're stored and which ones are used by the system. I wouldn't memorize all of these, but I just know that they're kind of high level. Your port numbers are TCP or UDP, and they number between 0 and 65,534. 65,534. That's it. Right there. Got it right. 65534. There you go. All right. You've got different type of switch networks. You're probably not going to run into any of these older ones. FDDI is still kicking, and Ethernet we're still using. Ethernet is always logically a star topology. So physically it can be all kinds of things, but logically it's always a star. Ethernet is going to have, you're going to have horizontal cabling and vertical cabling. Vertical cabling is going to be anything. It doesn't matter what the orientation of the actual cabling is. Vertical cabling is going to go between your MDFs and your IDFs, which are main distribution facilities and your intermediate distribution facilities in an organization, and then go out to your telco closets and other things. And then your horizontal cabling is going to be for that last little run over to each of your workstations, right? That's a high level on that. And then there's some email stuff here, email and different things that exist for email. And I would probably spend a little bit of time with those. I don't think you need to memorize those too much. Operations of hardware. What's a multiplexer doing? A multiplexer is just sending, taking multiple signals and aggregating them on a circuit. Multiplexers work on time division multiplexing, code division multiplexing, time division, code division, orthogonal frequency division multiplexing. There's a bunch of different ways to multiplex. And we're not going to get into those too much, but I have many, many lectures that I do on those. Orthogonal frequency division multiplexing is one of the most interesting things that I think humans have figured out so OFDM. If you want to go look up one of what I think is the most interesting things that people have managed to figure out about networking is this. And this is, there's really brilliant guys that came up with this. Frankly speaking, it's guys and girls, but I use the term generically. But yeah, so it's people. What they found was, where's my? Oh, here we go. What they found was, we've got this perfect wave going along like this, right? I know mine's not perfect, but every oscillation of a sine wave is a 180-degree shift. So from here to where it comes back to Yeah, I know that's like the worst sine wave ever. But back to where it comes back to the same line is an oscillation of a sine wave, right? So there you go. That's one oscillation. What they found was we could take all the frequency that we're using and we can shift it. So now if the frequency starts here and then we shift it here, we can have a point. And then we could find and then as if we shift it again, if we shift, so we got the frequency going, and then we move the frequency here, we can have another shift and another shift, and we can start to generate all these kind of things. Let me show you. Let me get a. I'm not going to try to draw it. Let me just pull this up for you guys. Here. OFDM example. And maybe somebody's got a good little guide on OFDM. So here's a signal. Now you start to shift, and watch what happens within a signal. You got equalizers and stuff. They've got all these different shifts here, and each one of these can represent a different number. And what can start to happen is you can get, within these different shifts of a line here, a tremendous amount of information. So now, instead of just sending a 1 or a 0, as I shift the frequency, I can start to send 64 different data points in one unit of a shift, as opposed to any one, like I could only send before a 1 or a 0, 1 0 1 0. That's all I could send you. But now, as the frequencies actually shift, I can send you up to 64 pieces of useful information in that one shift. So it's the shifting of the frequency that causes. Here's some other ones that probably show it pretty well. It is complex stuff, but it's actually how we get more and more density out of our system. So there's all kinds of stuff there. So anyways, go look up OFDM. It's really interesting technology, and you can build it inside of Python, it looks like. You want a little example that somebody did in Python, how they can get more and more data out of. Here you go. So if we're shifting it, here's the 0 0 0 0 0 0 0 1. So look at in one shift of a system, I can send any one of these points of data in any 1 second. So now I can send what can we represent there? 16 different points. 16 points isn't very deep. You can go. I've seen 64 points of data in one shift, and then I think there's even more dense ones nowadays. So they show the data here, and then they start to. I'm imagining they're going to send. Yeah. So as this data shifts, they're getting more and more data into that signal. It's tremendously interesting if you go and play with it. Here's all the data being sent. It's really interesting stuff. It is different but similar to frequency hopping spread spectrum, FHSS. And if you ever want to go read about frequency hopping spread spectrum, the creation of that is actually attributed to Hedy Lamarr, which is a female from the early 1930s. Hedy Lamarr was a woman who developed that, working on there is still a napkin that she drew it out on at like a happy hour in I don't think it's in the Smithsonian, but it's in one of our national museums. But frequency hopping spread spectrum, which was originally codified in the early 1930s, is still used by our military now. Our military still uses it for security on its radios, right? And there's a bunch of devices. You got to know your devices, right? And then there's other stuff. Okay, guys, how long have I been on here? I've been on here 2 hours, so I'll probably hop off here now. But we got some good lab stuff done for people that were around here earlier. We got the lab set up, and I've got the discs on there and that kind of stuff. She wrote it on a napkin, Robodom, yep. When she was first prototyping it out, yep. So, even if you guys aren't taking the CISSP, I think this is one of the best things you can go study and read about, like if you want to be more security minded. And even if you just then say on a resume, I was studying for my CISSP, that's still something, right? If you got nothing else on there, I'd at least put that I understand a lot of this stuff, and then be ready to talk to some of it. Some of this stuff, you could read through and then spin off and go do a little Google Safari on what is NIST 800-4? How is an intrusion detection system different than an intrusion prevention system? and how and why do I care? And then if I do care, how does that tie into what we call a seam or a sore solution, right? And what are these things and all these other stuff. So anyways, my point in showing you all this is there's a lot of stuff to go do, a lot of stuff to go read about, a lot of stuff to spend time with. I got to spend more time with my Prometheus in my environment and get ready for my PCA probably at the end of the year, or the end of the month here, not the year. Look for it for people that are in our Discord. Let me show you guys some stuff. Oh, whoops. Hold on. I don't want to pull that up. Let me show you guys some stuff about the Discord. Robodom, do you mind pinging that to everybody for the Discord again? This was, by the way, for people that were around yesterday and saw the problem that I had, this was the solution to the stateless image build, and this is how I got around it. And then there's a bunch of information here, but a couple things I want to show you guys. I always try to mention this. There are really good certs out there that are free that you can go take. I have no affiliation to any of them. Well, I have an affiliation to ISC Squared, and the guys, they have you know, 1 million free certs. I think they've probably gotten a few 100,000 of those gone now, but they've got a commitment to make the first 1 million free, so you can go take that cert for free, right? All these certs are free as well up here. So there's that stuff. And then another thing I want to alert your presence to before I go is we've got a talk coming up here from a bunch of different engineers in the industry, a bunch of different people that are part of the Professional Linux User Group, have been with us for a long time, and like coming to talk to you guys about systems and stuff. So if you want to hear it from people that work for, I mean, AWS and big companies and analytics professors for colleges and all of these things, we've got a lot of people coming to talk about that. And then if you need, I think I have it in here. I think I have it under conferences where you can go. This was like a little breakdown of all the people that were going to come and talk. This is the same thing that you just saw. And then the times are all in Arizona time. So I apologize, but if you do look them up in Discord, it'll show you it in Discord time. So it'll be your local time. So there you go. Boom. All right. So I pushed the Discord stuff because I think that's important. I think there's a lot of good people down there that are trying to get into the industry and work on the same stuff that maybe you are. So you can find other people that are like-minded and doing similar stuff, right? This is not contrary to popular belief, this is not the Scott Show. This is about getting people down into the Professional Linux Users Group and getting people better at this stuff. Roma, the CISSP is just theoretical. It's a lot of stuff to know. Yeah, we call it 5 miles wide and 2 inches deep. It is one of the widest. Actually, I can say hands down, it is the widest certification test I've ever taken. It was just so everywhere. Yeah, it's not the Scott Show. Tomorrow we'll be doing labs, so if anybody hops on, we will be in Killer Coda just hammering through labs, and we won't be making any labs. I don't make labs on Sundays typically. We will be just doing labs. So we're gonna keep going with Ansible tomorrow, and we will start at lab 9. If anybody's read the book or worked through the book, we'll be up in lab 9 doing the API stuff. Then we'll jump over and we'll do the lab out of the HashiCorp one where we go and access Vault from Ansible. So we'll be doing fun stuff. And again, the fun part of it's not that important. The practical part of it, I think, is what's important to you guys, right? Because that's where rubber meets the road, and that's where you go make money with this stuff, right? This is valuable. Companies need you for this stuff. So, all right, let's go to our little end of stream. We'll find somebody to raid. Turn the music off here, right? The music was getting a little. I need to get rid of that one. That's one of the songs I don't like as much. Let's go find somebody. We got Blaze, we got Sid. Let's go raid Sid. I like raiding Sid. He's one of the guys that kind of hangs on and does a lot of sound stuff. So we'll go raid over there. For you guys on the YouTube side, thanks for hanging out. I don't have anywhere to raid you off to, so I'll just say thanks for coming by, and I will see some of you tomorrow.